All right, welcome. It is Tyler from Arima Security Research, and today what we're going to do is go through my article, How to Use and Visualize K-means Clustering in R, originally published on Medium with Toward Data Science. So, K-means is a pretty popular topic. A lot of people like to do it in R, and, we're clustering things, right? So we're going to go over how to use the clustering algorithm. We're going to determine the right amount of clusters. We're going to create some tables, visualizations, that kind of thing. We'll download, extract, and load a pretty complicated Excel file from the web, and we're going to clean, wrangle, and filter things. So first things first, you should probably either go to the Arima website or the Medium link down below and have the article pulled up with you, so that way we can read along and copy some code out of it. One of the things that you'll want to do, obviously you want to read through it, but we want to make sure that we pull up the GitHub page, which looks like this. If I can grab it over, if Windows will cooperate, there we go. And we want to make sure we get the 2020 data. Every year they come out with new data. At the time I wrote it, we used the 2020. At the time I'm doing the video, I think 2022 is out. I haven't gone through it to see whether anything has changed or not, but I do know that the 2020 version still works. So let's go with that and make sure that we get it. So you can also find the completed R Markdown file and all that stuff there as well. In 5 chunks, what we're going to do is we're going to load some libraries, import the data, clean it up, show a couple different ways, kind of a basic and a fancy way of doing k-means clustering, and look at some visualizations that you may need. So first things first, we're going to open up RStudio. And what we're going to do is, this is just kind of the default place. Let's go ahead and make a new R Markdown file. So up here in the top, you can click on a little white page with a green plus sign. Click on R Markdown file. We'll call this Economic Freedom demo. Obviously we've already worked through this, but we're just doing this again. When you make a new R Markdown file, the rest of this junk is basically useless. You don't need this right now. You're not going to need it. So we just go ahead and get rid of it. I generally like to give myself a few extra lines. And first thing we're going to do is go up here and click on the green C with the plus sign in the top right corner to insert a new chunk. We'll go ahead and click that, click on R, and we're going to copy paste over the library and package information. So in R, if you run this chunk, where tidyverse, readxl, FactoMineR, and factorextra run through without a problem like mine did, then you're good to go. If any or all of these packages do not load for you, then what you'll want to do is uncomment out. So let's say that FactoMineR doesn't run, you get an error. It's probably because you don't have it installed. You can uncomment it just like I just did. If you have a cursor at the end of the line, you can do Control Enter on a Windows computer or Command Enter on a Mac to run just that line, and then I go ahead and comment it back out when it's done. Just remember, if you're going to install packages in R, that you want to install them exactly one time. You don't want to keep installing them over and over and over again. The more times you do that, the more likely you are to make R mad, and making R mad is not fun. So let's just stick to doing everything exactly one time. You can load the library as many times as you really want. Just install it only once. So next thing that we're going to do is set our working directory. If I can type instead of a $, we'll put that. Now there's 2 ways to do this. There's the easy way and the complicated way. And I don't remember the complicated way anymore, so we're doing the easy way. What you want to do is go over here to the kind of the bottom right quadrant where you have files, plots, packages, all that stuff. Go over to the right and you'll see these 3 little dots, go to directory. Now if you click on that, find a folder or create a folder where you're going to store all of this stuff, where you can store your markdown file and your data. I have my data already in a folder in a path called Economic Freedom. So what I'm going to go ahead and do is click on the More icon, click on Set as Working Directory. That is going to appear as code in your console in the bottom left quadrant. We'll go ahead and just copy it just so it runs better. There's a lot of reasons that you want to do it. The primary one is it makes your life simpler, and when you actually work out of a directory, you can just dump everything in there and it makes your file paths shorter, which keeps your sanity a little bit higher. So now that we got that in there, again, there's an easy way and a hard way to do this, so let's do the easy way. If you go back over here and see the name of our data, the index 2020, all of that data, we see this. Let's go ahead and click on it. Click on import dataset. I don't know about you, but I don't want to type that a whole bunch of times, so I'm going to call this EFI data. Go ahead and click over here on the code preview. Now let's look at this, because we've got a bunch of columns, a bunch of data. Notice how everything is characters. We're going to have to deal with that later. Sometimes you get data like that. I'm sure in here there's some missing stuff. Every once in a while you get a number like a double or something. But a lot of this stuff is characters, and we probably don't necessarily want that. So we'll deal with that in a minute, but let's go ahead and copy this middle line where it says EFI data, readxl, and then the name of our file. We can just copy it either with Control-C on Windows, Command-C on Mac, or we can right-click and do copy. I'm going to go ahead and hit cancel. And we're going to go ahead and import our data. So I just like to do it like this, that way you can run the file from top to bottom without having to do a manual process over and over again. So now we're going to go ahead and make another chunk. So we've got our data in, and we can take a look at it. So we can just click on it over in the Environment tab, and we see all kinds of crazy stuff over here, a bunch of numbers and all this stuff. I'm sure there's some missing data here, some missing stuff down here, like Libya and Liechtenstein and whatever. But you see how the NAs are written in/A? It's actually as a character format, not as a missing value. So we're going to have to deal with that. Again, that's one of our cleaning topics. So this is one of these steps, the next step that we're going to do here. You're going to have to kind of trust me on this, that we're going to want this, is something that we're going to do later is going to mess with something that's going to mess with our column names, and it's going to be annoying. So we're going to go ahead and get the original column names here. Just by putting them in an object called EFI data call names. We'll use the names function and just get our EFI data. So let's go ahead and run that, and you will see all of our column names appear here, and that just makes things easier for us. All right, so I'm going to go ahead and give a little bit of space to bump down. And then the next thing that we got to do is deal with this NA. And it's a weird NA because in R, NA is how it's supposed to be. In/A is either n divided by A, or it's a character that's just a string of things that doesn't actually mean it's a missing value. So what we want to do is use this little function where we're going to overwrite our data. So we're going to actually overwrite the EFI data object. So the way that we're going to do this, let's read from inside to outside. This gsub function, what gsub does is it substitutes one thing for another in a specific data set. So we're going to substitute our in/A with nothing, and we're going to use the data x. So that's going to be defined as a function that we're going to write, as a function between curly braces. All right, so x is going to be the data that passes in, and we're going to have EFI data be with inside an apply function. So we're going to apply our function that takes x to EFI data, which is going to be x, and then we're going to take the output of it and stick it in a data frame. All right, so let's go ahead and run that, and that is going to get rid of all those weird NAs. So if we go over here, let's find a few. I'm sure they can't be that hard to find. Here we go, like Syria right here. So we've got some missing chunks where they're actually set to nothing rather than NA. There's more than one way to do this. This just is the simplest way that I could find. And the other thing, if you've noticed, is we have like x.2020 score. Our spaces became periods. Some weird things happened to the name of our data columns. So we're going to go ahead and fix that. So let's put our original column names back. More for our sanity than anything else. And we're going to do basically the same thing we did, just in reverse. All right, where we're going to have the names of our data be set to the EFI data call names that we made earlier. So we go ahead and run that and take a look at our data over here. and we're back to normal. Right? Things are a little more easy to read, and it's a little nicer. So the next thing that's weird about this data set is that things come out as characters, and that is from them, not necessarily us. So I wrote this little function called toNumeric and roundfunc, a real original name, I know. But we're going to put in a function. It's going to take one variable x, where we're going to take x, our data, we're going to change it to be a character, and then change it to be numeric, and then we're going to round it to 2 decimal places. Now, I know that sounds cumbersome, and that might not be, sound like the most efficient way to do it, but from the perspective of getting it to cooperate with R, a lot of the work that you do is just getting the data that you have in a format that will work. So when you're dealing with characters, you want to make sure everything is a character, and then we're going to change it to numeric if they're all numbers, right? So that's the idea. So now that we've got that, we're going to do another fancy little function where we use mutate at. So if you're following along here, we have our EFI data. Well, into that, we're going to take the EFI data, and then we're going to pipe it into mutate at. So this % greater % thing, that's the tidyverse way of doing things. Makes your life a lot easier. We're going to take our data, and then we're going to do something to it. In this case, we're going to mutate at, and the variables is not one of the following things: country name, web name, region, and country. Right? So those aren't numeric anyway, so we're going to skip over them. And what we're going to do is we're going to mutate the rest of the variables using the toNumeric and round function. Right? So our data over here is a mess, objectively. Right? There's a lot of stuff going on. I don't really want to read that. That hurts my eyes to look at. Let's hit the button. I didn't run that. Okay, there we go. Helps to run the function first. So now let's go take a look at it, and that's a lot easier to read. Now, we can argue and say, did it introduce things that aren't precise? Yeah, sure. But I'd rather be able to read it than be 0.00001 more accurate. And plus, we're just learning how to do things right now. It doesn't really matter. So, there's a couple columns that we don't really need as well. Now, could we have selected them out? Sure. You can do this any other way you want. Just the way that I chose to do it, where we take our data, select a column, in this case country and web name, put them equal to null, so they just go away. Right? So we went from 34 down to 32 variables, and those columns, they're just gone. All right? We don't need them. We didn't need them anyway. So our last cleaning step here is anything that's left over with an NA, we're just going to drop it, and we're going to create that object called clean data. So we're going to make clean data. Into that, we're going to take our EFI data, pipe that into the function drop NA. If there's anything else that's missing, we're just going to drop it. Right? So we're going to go from 186 down to about 179. So we'll drop, if I can still count, 7 observations, and we'll go from there. So we've dropped those out, and now we've got the fire truck singing the song of its people out there, and they're really excited about R. But let's go ahead while it's doing its thing. Let's do our thing and set a seed. Now, the whole reason you set a seed is that R doesn't actually generate random numbers, and it doesn't actually randomly sample anything. It uses pseudo-random sampling. So, the state of our machine is what determines whether where random starts. So if I have a seed of 1, 2, 3, 4, and you have a seed of 1, 2, 3, 4, our random that gets generated is going to be the same. If you had a seed of 100 and I had it as 1, 2, 3, 4, we're going to have different versions of random. But if we have the same version of random, we should get the same distribution of things. So we just do that, to make sure that we're all on the same page, and it ensures reproducibility. So we'll go ahead and run the seed. And now we can actually start doing kmeans. So the first thing we're going to do is talk about the basic way. They just kind of getting you the answer. So what we're going to do, and it doesn't quite paste exactly correctly from Medium, which is fine, we're going to do the simple kmeans function. So we're going to create an object called kmeans basic, and into that we're going to use the kmeans function, take our clean data, and we have this weird little thing right here where it's square bracket, comma, 7:32 square bracket. So what that means is columns 7 through 32 we're going to take as our data. And the reason we're doing that is because you never include ID numbers into anything statistical. It just doesn't matter. Country name, region, who cares? We don't really want to bias ourselves with the world rank, the region rank, of the 2020 score. Now we're trying to cluster these things. That's kind of cheating. So we're going to start with column 7, which is property rights, and that zooms all the way over all of these other categories, and you can read through them on your own, but that goes all the way to public debt as a percent of GDP. We're going to take those all together, and that's how we're going to generate our data. So what we're going to do is, create the actual clusters, and then we're going to have to put them in a table. So one of the things that kmeans will do is get the size of your cluster, like how many things are there, and what the centers are. So when you have the centers, that's, each column is going to have a center within each cluster of what everything is clustered around. Kind of an obscure idea, but we'll build on that when we take a look at it. And then we're going to take our results, put it in a data frame. We're going to create a cluster column and put on the cluster number onto our clean data, so that way we can easily see in a table which cluster something is in. All right, so let's go ahead and run this. And if I've actually run everything, it should go. So now what we're going to do here, let's take a look at these data objects one by one at the kmeans basic. It's going to be a list of things. And our lists handle, have multiple data types. They're pretty handy when you get to work with them. But we have clusters and centers. A lot of this other stuff, it's not really all that relevant to what we're doing, but we have, which cluster everything is in, along with what the centers are going to be of each column. And notice there's 26 of them. So we have 5 clusters, 26 columns that actually got passed in. And we'll be able to see that here in our next thing. So taking a look at our kmeans basic table, if we look at that, we see that we have 5 clusters. Now, is this exactly perfect? Not really. You can adjust this. You can put 4 clusters in. You can put 3. You can put 2 if you really want. You can put 17. Doesn't really matter. But it's obvious that we have 2 main clusters. One that's 45, one that's 123, and there's some other ones hanging out over there. The 45, tends to have better property rights, more judicial effectiveness, more government integrity. There's some reasons. I would encourage you to form your own opinions and look at the data here about which countries are in category 1, 2, 3, and 4, and 5. But you can clearly see that a country in cluster 1 tends to be, a better economic situation. Now, I'm sure there's some exceptions to the rule. But you can take a look through each variable, and there's some interesting things to discover in there. I will leave that to you. And we'll move over to our kmeans basic data frame. So if we take a look at our data frame, we see that the country ID and the country name and all this stuff, which cluster they're in, right? So which cluster is in which thing. You can take a look. It's very interesting to see how this works. Again, I will let you explore that on your own and form your own opinions about that. The point of it is we have all of our countries clustered into which cluster, and we've got a table, and you can do whatever you want from there. One of your possibilities is to make a chart similar to this, where we can use ggplot, which gets loaded with tidyverse, to make a basic bar chart. So we're going to take our data as our kmeans basic data frame, and we're going to sort it by cluster. We're going to clusters 1 through 5. We're going to make a bar chart and fill it by region, title it, and center the title. Let's go ahead and run that. And you can see the breakdown of regions within each thing. I will, again, let you make your own opinions about why cluster 4 has so many of Asia Pacific, Sub-Saharan Africa in it, and the Americas, and which Americas go in 1 and 4, interesting question. You can explore that on your own. So that's a basic kmeans thing. You can do whatever you want now that you got them all clustered. So I have no idea what you want to do, but you have them clustered, and there's a basic way to visualize that. So that's the easy way. Now we can do it a little bit fancier. So kmeans is worried about how far away you are from the center. And one of the things that we can do is scale data to make it a little less far away. It's a that or another normalization technique can be used. You can experiment with this. I'm just going to scale it using the base, like the base R function scale, like we've got here. But we're going to use the fviz nbclust function. That's a real mouthful. But what it's going to do is take in data. We're going to scale the same data we just used. So we used the raw data last time. This time we're going to use the scaled version. We're going to use the kmeans algorithm. We're going to do it 100 times. We're going to use the WSS method. I don't remember what that is, but that was what's in the documentation. Seems to work good enough. And then we have a vertical line that's just going to show up at 5. So this is what's called a scree plot. And generally how you use these things is you use it to select a number for k. So, 1, if you put everything in one cluster, well, you're not clustering anything, right? That's kind of silly. 0 clusters is even sillier. And 2 clusters, can you do that? Sure. Is that really going to help you all that much? Probably not. But if you see how from 1 to 2, we have a really steep line, 2, 3, and 4, all the way down to 5, basically a straight line down, right? The slope is basically the same. But you see how 5, it kind of starts to break and trend down. So can you add more clusters? Sure. Do you need to add more clusters? Probably not. Normally when you're using a scree plot, you just kind of pick the one where it looks like it's breaking to where it really slows down. Can you do 6 or 7 or 8 or 9? Sure. You should certainly experiment with it. You can change the number of k. It's fine. But I'm going to stick with 5. So when we actually do that, we go down here, and I have it written as kmeans fancy. We're still going to use the kmeans function, but we're going to scale our data this time. Our k is going to be 5, and we're going to do it 100 times just to make sure. And then we're going to plot our clusters, kind of the same idea. The fviz cluster takes our kmeans output, takes the data, the underlying data. It takes what kind of point you want, because it kind of builds on ggplot, and our ellipse type is going to be built around Euclidean distance. You can change that if you'd like. I probably wouldn't, but you can. So we're going to end up with a chart that looks something like this, where it's pretty clear that cluster 5 is doing its own thing, cluster 1 is doing its own thing, and cluster 2 is doing its own thing. Do they overlap a little bit? Sure they do. Are they more around the centers of things? Yeah. Cluster 4, who knows what's going on with that one. Cluster 3 is hanging out up here in the corner by itself. So you can visualize this another way as the data points that go around. The better you are at ggplot, the more you're going to be able to get out of it. But as far as, finding a k and doing all this stuff, you can kind of mix and match these things. A lot of times the hard part is actually just getting over the hump to get the stupid thing to work. And once you got it, then you can do whatever you want with it. So I hope that this helps get your kmeans clustering algorithms working, and that you can get where you're trying to go with it. So again, this has been Tyler with ARIMA Security Research. Make sure that you give us a like, make sure that you go ahead and subscribe, get on our email list, and we'll have more videos coming about machine learning with R and Python, probably some database stuff with SQL coming up relatively soon, and we'll do some networking and cybersecurity while we're at it. So keep in the loop. Don't be a stranger. And until next time, we will keep mashing those buttons.